Greetings to all of you. We're here with another session of basic electronics training, and in this session, I want to talk to you about another topic related to electronics and introduce you to this subject. So stay with me. The topic I want to cover in this session is about electric charge. But before that, as you may remember from the previous session when we talked about electricity, we said that in order to really understand what electricity is, we need to get familiar with some concepts like electric charge. And we also mentioned that it's necessary to look at the structure of the atom itself to see what it's like. Therefore, to better understand electric charge, we need to see what's going on inside the atom. If you remember your school days, whether elementary or other grades, they told us that matter is made up of very tiny pieces called atoms. And these atoms are so small that, for example, a single dot you put at the end of a sentence might contain trillions of atoms. The word atom actually comes from a person who lived in ancient Greece named Democritus. Contrary to what we said, that atoms are very small and, for example, even a single dot might contain trillions of atoms. We can't say that the meaning of atom is very small. In fact, based on its ancient origins in classical Greece, where the fundamental concept of the atom was originally named, the very word atom itself profoundly means indivisible, signifying something that cannot be further cut or broken down into smaller parts. So it's better to say that the atom is the smallest part of matter. When we keep dividing matter into smaller and smaller parts, we eventually reach a point called the atom. And after that, matter can no longer be divided. That means we can no longer break it into smaller pieces. In other words, I can say that if we divide an atom of a specific element, the resulting pieces can no longer be considered that element. So when we reach the atom, and even if we try to divide the atom itself, it is no longer the same element. For example, let's suppose here that these are several pieces of chalk and I kept breaking them down until I reached, say, a single atom of chalk. Now, when I meticulously reach the fundamental atom, I can go ahead and further divide it, carefully breaking it down into its constituent pieces. If we could, for example, take this atom that belongs to the chalk or any other material like copper and split it in half, the resulting piece, we can no longer say that it is still chalk or that it is still copper. Instead, we can say that now that we've managed to split the atom, this atom itself is made up of a collection of fundamental particles that together form the atom. We can consider three fundamental particles for this atom. What are these three particles? Neutron, proton, and electron. It's true that we initially defined the atom in its literal sense as indivisible. But that was back when people couldn't see beyond the atom, or so to speak, split open the atom to see what was inside. That's why, for example, the smallest piece of any substance they could obtain was called an atom, and they believed that nothing smaller existed beyond that. But gradually, as science advanced and with much more precise instruments, they were able to see that, in fact, there are other particles inside the atom as well, and there's actually a whole other world in there. Through experiments, they identified and named three fundamental particles: the neutron, the proton, and the electron. Now, if we want to categorize where these three particles I mentioned are located within the atom, neutrons and protons, for example. Neutrons and protons are located at the center of the atom, as you can see in this image, the green circle and the red circle with the plus sign inside it. These are called protons and neutrons. That is, the one with the plus sign represents the proton, and the green circle represents the neutron. They are located at the center, or in other words, in the nucleus of the atom where they are stuck together. Surrounding this nucleus are the electrons, which orbit around the nucleus in a path, and we represent them with a negative sign. These representations are conventional. That is, it's not something that we can say has definitely been proven to have a negative charge. It has a positive charge according to a convention so that they can perform the calculations they have in mind. they decided to represent the electron with a negative sign and the proton with a positive sign. Now, among these, the neutron has a neutral charge, meaning it is neither positive nor negative. It has a neutral charge, which we'll explain more about this matter later. This is a simplified model of the atom, which you might have seen since childhood in various books, where they showed something like this and said this is a model of the atom. For example, they called it the planetary or solar system model, similar to our own solar system where the sun is at the center and the other planets move around the sun in specific orbits. And this is a simplified representation of the atom that has been shown to us in this way. Of course, we should say that this is a simplified diagram, but if we want to understand atoms better and know what they really look like, we can say that instead of electrons being placed in defined orbits like this, in reality they form a cloud and revolve around the nucleus. Now, this is a schematic that, if we want to look at the first model in 3 dimensions, it is considered like this. The nucleus is fixed and located at the center, and the electron is revolving around this nucleus in an orbit. This is a 3-dimensional diagram and is meant to help us understand it better. But as I mentioned, according to other experiments, and if we want to look more precisely at how the electron behaves, and in the future, well, as we said, the electron plays a very fundamental role in electronics. To see more precisely what shape it has, they say that the electron moves around the nucleus in a cloud-like space, which is called the electron cloud. For example, if we want to consider a simple example of the electron's movement around the nucleus, we can say that the electron does not revolve around a single ring. It might exist anywhere around the nucleus. Electron clouds have strange shapes and properties, and in a strange way, we can say it's almost impossible for us to know exactly which part of this space an electron is located in. Now, if I want to show its shape more precisely, for example, we can say that it looks like this, and the electron can be located in any part of this cloud. Now, if we want to see more advanced examples or more optimized and advanced images of the presence of electrons around the nucleus, it would look like this. In the field of chemistry, you can explore the topic of electron clouds in even more detail. If you're interested in this field, you can explore further. If not, and this level is enough for you, we can wrap up the topic here. And now there's another, even more precise depiction regarding the electron and that cloudy space we call the electron cloud, which you can see in the last image. And we've moved from that simplified model, which represents the internal structure of the atom, to this structure, or the one shown in the upper right corner. So this is what the structure of the atom looks like, and we can't say that the electron is exactly here, for example. This leads us into a topic called quantum mechanics. And well, it would get very complicated if I were to get into quantum mechanics right now, because as we said, electronics starts from the basics. We're moving forward gradually and step by step to understand what electronics is. And for now, we're sticking to the fundamental concepts. Alright, let's continue with the topic and see how all this explanation about atoms relates to electric charge. So we said that the simplified model of the atom looks like this. Now, before we move on with the topic, let me give you another example here. Atoms usually have the same number of electrons as protons. That means in this state we can say they are neutral. So for example, if I consider a copper atom, the copper atom has 29 protons in its nucleus, as you can see here, and 29 electrons orbiting around this proton nucleus. If you recall the image from the previous slide, you'll see that we can't really say that the electrons are just orbiting in a single shell, all 29 of them like that. Instead, in a cloud-like space, 29 electrons are moving around the 29 protons that are gathered together in one place. When an atom, for example, this copper atom, gains an extra electron or somehow loses one of its electrons, in this situation, we encounter a term called charge. As I mentioned, for example, this copper atom might gain an electron or it might lose an electron. And obviously, in these situations, the copper atom changes a bit. Why? Because it has gained an extra electron. And we said that in a neutral atom, the number of electrons and protons is equal. Now, if this same atom gains an extra electron or loses an electron, its properties will definitely change as well. We represent protons with P and electrons with E, which is usually shown as a lowercase e, meaning the lowercase English letter E. So from now on in the topics we cover together, whenever I use a lowercase e, that indicates an electron and protons are represented by P. Well, as I said, when an atom gains or loses an electron, what this means for us here is that something called a charge is formed. Alright, now let's continue the story. We said that atoms are made up of three particles, electrons, protons, and neutrons. Now, out of these three particles, the two that are most important to us are the proton and the electron, because the concept of charge is what we want to derive from them. These electrons and protons have a very interesting property, which, as the title of this topic suggests, is electric charge. This interesting property is electric charge, which can be either negative or positive. And as I previously mentioned, by common convention, electrons are universally considered to possess a negative electrical charge, while protons, in contrast, inherently have a positive electrical charge. Yeah. As we can see in this image, electrons are symbolically shown with a negative sign and protons are shown with a positive sign. They've displayed it here. The most important thing we need to know about charge is that opposite charges attract each other. That is, if my charge is positive and we have another negative charge, they will attract each other. Or in other words, if we have a proton and an electron and they are placed next to each other, they will attract each other. Just like in this illustration where you see the electron moving around the proton. Why? Because the electron has a negative charge and the proton has a positive charge, and these two attract each other. This is a property that we attribute to electric charge. Another point is that if we have two negative charges, when we try to place them next to each other, they repel each other, meaning they move apart. The same property applies to two positive charges as well. That is, if I try to place two protons next to each other, I can't bring them very close. They can only get so close to each other, or the same goes for two electrons. Beyond that, I can't put them any closer together. If we want to have a tangible example of this concept and be able to imagine it, a magnet. You see a magnet. For example, if you put two magnets next to each other, you'll see these two magnets attract each other. Now, if we try to put one side of a magnet next to the opposite side of another magnet, we'll see that these two can't attract each other. The same idea applies to electrons and protons. Suppose you want to put two electrons next to each other. They don't stay together, which you might say is a bit contradictory compared to what we see in real life. We always say, for example, that two people with similar traits usually get along better and stay together. But when it comes to electrons and protons, or positive and negative charges, it's actually the opposite. If their charges are opposite, they attract each other and come together, but if their charges are the same, they repel each other. So to sum it up for you, we consider the electron to have a negative charge and the proton to have a positive charge. Or we say that the electron has a negative electric charge and the proton has a positive electric charge, which are generally defined based on certain conventions. This is mainly for mathematical calculations, not because of any deeper physical reason. Now, the attraction that exists between these protons and electrons is what allows us to have atoms. That is, if the electron and proton are positioned together in a certain way, we can say that this is an atom, specifically a pure or neutral atom. And this attraction causes the electrons to remain in their orbits around the proton or the nucleus and maintain the neutral structure of the atom. Now, if another electron is added to this orbit, or if an electron is removed from this orbit, then the atom itself will have a different charge, or it may acquire another property. But if I want to talk about electric charge in general, considering what I've discussed so far and the details I've tried to explain, electric charge refers to a fundamental property of matter that even brilliant physicists like Stephen Hawking have not yet been able to fully understand. So, as I said, it's mostly a conventional concept and has a mathematical aspect, and for calculations like these, we consider it as such. It's enough to say that there are two tiny particles that make up atoms. What does that mean? It means that this electron here and this proton are two tiny particles that make up our atom and carry electric charge. By carrying electric charge, it means that it has a negative electric charge. The electron has a negative electric charge, and the proton has a positive electric charge. So we have two types of charge, positive charge and negative charge. Electric charge is also one of the fundamental forces of nature that holds the universe together. Why? As we said, the proton has a positive charge, the electron has a negative charge. These two come together and attract each other, or are attracted to each other, and this causes the atom to form, or for the atom to have its own structure. When the atom has its own structure, naturally matter is formed, and in the same way other materials are formed as they come together. And overall, we can say that the presence of electrons and protons together is what holds our universe together and keeps it stable. Therefore, the attraction of negatively charged electrons to positively charged protons keeps the atoms together. If an atom has the same number of electrons as it does protons, the positive charge of the proton and the negative charge of the electron balance each other out, and we say the atom is neutral, meaning it has no electrical charge and is called neutral. However, if an atom loses one of its electrons, it will have one extra proton. For example, consider that same copper atom. We said it has 29 electrons. It has 29 protons. If one of those 29 electrons is lost, it becomes 28 electrons, but the number of protons remains 29. So the number of positive charges is greater than the number of negative charges. Therefore, we can say that this atom has a positive electric charge. Now, if we have 29 protons, there are 29 electrons, but depending on certain reactions or if other substances add another electron, it becomes 30 electrons. With 29 protons in this case, the number of electrons is obviously greater than the number of protons. This means the negative charge becomes greater than the positive charge, and our atom acquires a negative charge. Now we said that if an atom loses an electron, it becomes positively charged, and in general, the foundation of this world is based on balance so that equilibrium exists. When an atom is in a neutral state, it means it is in a state of balance. It has lost this electron. It is constantly trying to attract another electron to itself so it can become balanced again. And when it has gained an extra electron, it is always striving to somehow lose this electron and return to its neutral state again. This is the concept of electric charge, which, as I mentioned, is a kind of convention. For example, it's just the movement of this electron that makes us say an object has a positive charge or an object has a negative charge. By charge, we mean the number of electrons. Technically, as we said, all atoms are neutral in their normal state. They're not really after anything special. They just want to maintain their own state of equilibrium. Or as they say, they have neither eyes nor minds. They just have some electrons, and around them there are some electrons farther away. For example, imagine an atom. At its center is the proton and some electrons are close to it. Some electrons are at a farther distance, and those that are farther away are more likely to leave the atom. However, the proton at the very center of the atom exerts a powerful force that effectively keeps even those electrons that are farther away orbiting continuously around it, thus meticulously maintaining the atom's overall neutrality. So, in electronics, we learned about the concept of electricity and electric charge. Up to this point, we've learned two concepts related to electronics and saw what electricity actually is, which, simply put, is just what we call barg electricity. Specifically, we're talking about electric current. It's the same as electricity. The second concept was electric charge, which we defined as the increase or decrease in the number of electrons associated with an atom. We said that an atom is neutral in its normal state. That means the number of electrons and protons are equal. When this balance is disturbed, it causes the atom to gain a charge. The charge might be negative, or the charge might be positive. If it loses an electron, it becomes positively charged, and if it gains an electron, it becomes negatively charged. And keep this in mind as well. When an atom loses or gains an electron, it's no longer the same atom as before. This atom changes and acquires new properties which can also lead to other processes. Here we have only discussed the fundamental topic of electric charge, but later on we will be dealing with it much more extensively in the field of electronics. A simple example is when your hair gets attracted to a comb. That's the same topic of electric charge. Why? Because electrons might have transferred from your hair to the comb, meaning your hair becomes positively charged. When it loses electrons, it gains a positive charge, and the comb, which receives the electrons, becomes negatively charged. And as we said, positive and negative charges attract each other. That wraps up the topic of electric charge. Now, if you have any questions about electric charge, I'd be happy if you ask them through the contact methods provided to you. And if any point was missed here or you feel it needs further explanation, be sure to let us know. So until the next session, where I'll talk about another concept related to electronics, I hope you'll watch these sessions we've had so far once more, understand the concepts, and look for real-life examples in your daily life. So until the next session, goodbye for now.